This is 2014 question 5. This is one of those miscellaneous questions that really doesn't belong to any of those popular FRQs, okay? Here we go. So notice how in the table they provide you a lot of facts, okay? It looks a little bit weird, not what we're used to, but this is pretty much a sign chart, okay? If you guys take a look here. -2, -1, 1, and 3. And then they tell you what happens in between each section, okay? And depending on what you're looking at, it'll give you different implications there. So just keep that in mind. I'll show you how we use it in a second. Here we go. Part A. Find the x-coordinate of each relative min of f on the interval from -2 to 3. So remember, relative min is just local minimum. So remember that f has a local min when what happens, right? So you got to remember that this is when f prime changes from negative to positive. Okay, so where is f prime? Boom, right here. Okay, f prime. Okay, so first remember, you got to look for your critical numbers first. Here are your critical numbers. This is where your derivative is 0. Okay, so looking at this here, I have the sign chart, and here are my values, negative, negative, positive, according to f prime here. Okay, so does f prime change from negative to positive? It does at this x value right there. So we're going to say at x equals 1. And obviously justify your answers here since, and I'll let you guys do the rest, okay? Here's part B. Explain why there must be a value c somewhere between -1 and 1 such that f double prime of c is equal to 0. Okay, so this one is a little bit tricky. It's one of those, what do they call it? Existence theorems, okay? So first off, I'm going to have you guys only look at everything in between -1 and 1 here, okay? So explain why the second derivative has to come out to 0. So if you guys notice here, there is no second derivative of f. So the furthest that we have is actually f prime. So the derivative of that is going to be f double prime. So we notice that here at -1, we have f prime of -1, okay? And at 1, we have f prime of 1. So using what we know about the values, let me take a look here. F prime of -1 is 0. Okay, and so is f prime of 1. Okay, so even though we're at the derivative level, okay, we can still find the average rate of change, which is just y1 minus y2 over x1 minus x2, right? This comes out to 0. So you guys have this random derivative graph. I don't necessarily know what it looks like yet, okay? But you know that the average rate of change, or the slope of a secant line, is going to be 0. So the slope here is 0. So does that guarantee that there's going to be a tangent line that's parallel to it? Okay, this is the mean value theorem. So the mean value theorem is going to work, but only if the conditions are met. So review back to your two conditions, okay? So remember that the function needs to be continuous on a closed interval, but differentiable on an open interval. Okay, so do we have these facts? Okay, so we do right about here. I'll highlight it in blue. They stated that the functions are twice differentiable. So meaning that they're differentiable, but remember the implications. if a function is differentiable, then it is also continuous. So we actually know that these two conditions are met, so you just have to explain it. So take a look at what they did here. They stated that f prime is differentiable and continuous. Okay, this right here is really just the average rate of change, but just written in a very abstract way. And then you would just conclude it by MVT. There is a possibility where that'll happen. Okay, here's part C. The function h is the natural log of f of x. Find h prime of 3. So they introduce a new function h of x. Okay, we have to find h prime of 3, but before we do that, we need to find h prime of x. Okay, how do you take the derivative when there is a function inside of another function? Right, f of x is inside of your natural log function, so we have to apply the chain rule. So we take the derivative of the outside. So derivative of natural log is just 1 over, right? 1 over the derivative of the outside of the same inside times the derivative of the inside, which is f prime of x. That is the chain rule right there, okay? So all that's left to do is just plug in 3 for x. So we have 1 over f of 3 times f prime of 3, okay? How do we get those values? It's in this giant table right here. F of 3, if you're looking at it correctly, f of 3 is 7. F prime of 3 is 1/2. That's enough for equal is equal. You don't have to evaluate it unless you want to, but you don't get any extra points, okay? Here's the last one, part D. Evaluate the integral of this really initially complicated looking integral, okay? So what do? I noticed right away, let me erase this so that we have room. I noticed that there is a function inside of another function. I noticed that g is inside of this function here. So what you have to do is, although it looks complicated, they're really telling you to let u be the inside function. Okay? If u is g of x, then the derivative of u is just the derivative of g dx. Okay? So take a look. G of x is going to be replaced with u, okay? And g prime of x dx, take a look here, we have a perfect fit. That should equal du. So if you plug it in, you're going to get the integral of f prime of u. And instead of g prime of x dx, that's just du, okay? So notice here how everything is in terms of u, okay? So what you have to do is you have to change your bounds. Everything has to be in u now. Initially right here, x is equal to 3. And here x is equal to -2. So to find u, we're going to take this here and we're going to plug it into there to find out what u is. So u is equal to g of 3. Well, what's g of 3? Take a look back at your table. G of 3, if you're looking at the table carefully, it should be 1. So your new upper bound is going to be 1. So if you plug in -2, u will equal g of -2. If you look at the table back again, g of -2 should be -1. So here you go. Okay, that's the first big step. Now, how do you integrate a derivative? Okay, that's the fundamental theorem of calculus. If you take the integral of a derivative or vice versa, you end up just getting the function. Okay, so this would just be f of u, but then you plug in your upper minus your lower. Okay, and I'll let you guys figure out what those values are in the table, okay? But that's pretty much it. They wrote it in a very fancy way. I'll leave it at that, okay? I think the way that I explained it is a lot better, but feel free to try to follow what they're doing there, okay? And that's it.